KN4YB. Good evening. Thanks for clicking on the video. And it's a video that not related to any of my hand keys that I build. Of course, it's amateur radio related. And one of the avenues of the hobby is I like to enjoy is build my own transmitters and vacuum tubes. And it's one of the reasons why I got into the hobby, because I had a fascination of vacuum tubes when I was a kid. Practically everything that I watched or heard from had tubes in them. And well, this video is about how to build a pi network using a antenna analyzer, also known as a noise bridge. And you can pass frequency in through a pi network either way, and to find out where it's resonant, and that you're not shooting in the dark when you're building a transmitter, or you're relying on information that might be as accurate for you as it was for the person who authored the page of transmitter plans that are prevalent on the internet. And I've known this for several years, and I've talked to other builders and they don't know about this, and I'm sure I'm not the only one, but I like to get this information out to guys who like to build. And so a pi network, you can go and look up what is a pi network. It's been in vacuum tubes after the war, World War II. It's for coax and for 50 ohms. And this setup here is familiar to hands that have been in transmitters. This is this is the antenna, what they call the antenna coupling capacitor. This is your plate load capacitor. This little toroid, which I've measured at 8.6 microhenries, is around the 40 meter band. Now, what's not you seeing is a resistor. This is a representation of load resistance of the vacuum tube that's in question. Now, you can find the information on data sheets. If you have a handbook, you can find what is the load resistance of the tube, and the one that I have an interest in building a network for is the 6AG7, and it's a little 3-watter that I want to build. And the load resistance is 10,000 on 10K. So we strap a resistor to the positive, to the ground on the end of this network, and this will after manipulating the caps and 50 ohms going in, this is how I know I have a resonant circuit and that it's accepting energy into this resistor. So, I'll give you an idea. So I'm at 7, but see, I usually start off under and see where things might be, because I like to make the coils longer. And when you make them longer, that means your frequency is going to be lower. So if I have a hard time seeing the meter up into the bridge here and look for the dip, what I do is I go and half mesh the plate capacitor and then use the meter to sweep. And there I'm dipping down pretty close to 50 there. I'm at 6.88. Well, that's not bad. Now, let's see if the second capacitor comes into play. Yeah, it does. It starts to bop it down flat, and I'm pretty sure that I am close to where I want to be. So let's kick this up a little bit, because your hands will affect this. This is very convenient where you can just sweep. And we're like not about the middle of the band there, and there I am, and then I could dip, and I'm zeroed out here, and there I am. So when you build a network, you want to start your coil a little longer, and then as you play and manipulate with the frequencies, you want to get where you're about half mesh, and you want to where you come in and use this cap. Now I have a transmitter, I have a Johnston Adventurer, and you don't need the dip. This thing passes out at 50 ohms, no return with the cap, this cap. And it's possible to do that. And actually, I have an idea with this little transmitter. I want to eliminate this cap. And is that possible? And I will say yes, it is. So let's go down and lower frequency. Alright, so we're not quite... See, this cap no longer plays in getting it flat. If I kick the cap up, it won't flatten down. And I'm at 6, almost a full megahertz down from where I was at. So let's kick this up a little bit. Sweet. And at 637, closer, but this cap is not doing anything. Yep, here we go. Now I just mashed this down, and that transmitter would pass frequency out at 635 without having to reduce the value of this cap. This cap's around, well, it's 2-section 365 broadcaster. So let's go ahead and move this little cap up a little bit, and yeah, about 650. And would this make a change if I kick this up? No, it did not. There's no dipping. You can't dip here. The lower frequency. So you smash that down. So again, I have a Johnson Adventurer that passes out without having to touch this. If you try to dip, it's useless. You don't gain anything, and the SWR stays the same. So that transmitter is basically built to where the broadcast doesn't come into play into a 50 ohm load here. This is something very important. So now let's sweep up in frequency and go up, and here we go. We're pretty there. We could probably start getting into the dipping, but still, we're still passing out fairly flat at 6. Now let's move up to 6.8, and it's starting to lift. It's starting to lift up here. So we'll start. See, now we're getting into the region where we start to use the other cap. There. So at 660, this is where this has to come into play to make sure that resonance is passing on to this resistor, 10K. Now, like 6L6, 807s, they're in the region anywhere from 4 grand to 5 grand load resistance. Again, all the power tubes are listed up in the book, and load resistance is what you got to find out and make sure that this setup works for you. And this has saved us so much time and tube life, because the frustration of trying to get a network to work and you're not even close, and that poor tube is not passing out. So, to make this a short video, now I've made, with the noise bridge, I've made phasing stubs for end-fed dipoles. This is not just an antenna tuner, this is also a tuner. When I work a tube station, I take a fixed tuner and tune to what frequency, which is 7 megahertz, and I flatten out the curve with the tuner to the line, and I never have to worry about, I don't use my Pi network with that. It just goes out, and no worries about that. So there you go. Hope you're enjoying your evening or day. And 73 KN4YB.